Dear students, let us continue our learning the course System Software and Compilers. This is the third session of the module 3. The topics covered under this session are under the chapter Syntax Analysis. The first one is the context-free grammars. Under the context-free grammars, we are going to learn the formal definition of context-free grammar, notational conventions used in the context-free grammars, derivations and parse trees and derivations of the context-free grammars. Myself, Dr. Suresha.d from the Department of Computer Science and Engineering of Canara Engineering College, Bantvald, Mangaluru. To start with, what are context-free grammars? Context-free grammars, what we are learning from the last semester of the automata theory and computability. So these are the grammars which are not dependent on any context and they are applied as in the rules part of the syntax analysis. Right? So the grammars are they describe the syntax of the programming language. Programming language constructs like the expression and the statements. Right? So let us take the example. So the example stated over here is for the if statement. That is, we have for the if statement, the statement will derive as starts with the if, then the open parenthesis, then the expression, then the close parenthesis, then the statement, else the statement. Let us take the example. How it will be? First, the statement will be an if, then it will be the A greater than B and A greater than C. Then we will have the printf A is bigger, else again one more if I will place if B greater than A and B greater than C, then again in this one printf here I will print B is bigger else printf C is bigger. So now in this example, we start with the statement. So that is the statement derives. First will be a keyword if, followed by the open parenthesis. Then this whole thing which is present inside the closing parenthesis. That is in between the opening and the closing parenthesis. The contents we write it as the expression over there. The next will be the again the closing parenthesis. Next to that one will be the what to do if the condition is true. That is the first statement. If the condition fails, then we will go to the else over there and again there is a statement. So now that statement, again it can have the if statement. Again it can have the if statement or any other statement can be valid over here. Fine. So this is how we write the grammars for the if statement. Then if you take the example of the declarative statements. So how the declarative statement will be? Statement will give us the declarative statement. So declarative statement, let me call it as a DL over there. So that declarating statement, how it will be, that will start with the first will be an integer declaration. Let us take, let me write it as a data type. Let me write it as a data type followed by the variable list, then ending with the semicolon. The variable list, if I take up, it will derive as the that is a variable. It will be having the variable list, comma variable, and the or it will end on the single variable. Then the data type, if I take up, it can be an integer, it can be an integer or floating point number, or it can be in character, or it can be in number. So how this will be matched with our declarative statements? How the declarative statements will be? It will be int, then followed by a space, then a comma b, then the semicolon. So first what happens? Statement derives the declarative statement. Declarative statement will start off with the dt over there. What is dt? dt is in data type. So data type is an integer followed by the variable list. So variable list, you will have the variable list, comma variable, then this will be matched. Then again the variable list will give us the variable. This will be matched. Okay. So this is how the grammars are written for the programming languages. So I hope it is clear with the writing the context-free grammars. So under while we go for writing the grammars, what are the conventions we follow? What are the conventions we follow in the writing? What are the things which are present in the grammars? If you take up the grammar which is stated over here, so in this grammar, there are some the things which are continued and which are ended. Let us take the example of DL. So DL is continued. DT is continued. VL is continued. But semicolon, it is not continued. It will stop. Then in the same way, VL, again the VL is continued. Comma, not continued. Variable, not continued. Right? The one which is not continued means they are the ending point. So for them, we call them as the terminals. That is, terminals are the basic symbols from which the strings are formed. The term token name is a synonym for the terminal, and frequently we use the terminal to represent the foreign token for the terminal. Means whatever the tokens, these are the ending points. These are our leaf when we construct the tree. Right? So that is on which we end. So in the previous example, what are the tokens which are present over there? If, open parenthesis, close parenthesis, and the else. So these are the terminals which are present. These are the terminals. Right? Then the non-terminals which are not ended, they are continued. They are not ended, they are continued. So them we represent as the non-terminals. In this example, the non-terminals are DT, VL, then it will be dt vl, then it is dl, that is for the declarative statement, dt for the data type, vl for the variable list and the statement. So they are the non-terminals. So in this example, textbook example, the non-terminals are, first one is statement, expression, statement. Here this statement, they are the non-terminals. So that is, non-terminals are the syntactic variables that denote the set of strings. Example, statement and expression are the non-terminals which are present. The set of strings denoted by non-terminals help define the language generated by the grammar. That is, non-terminals are used to impose a hierarchical structure, that is a tree structure on the language, that is a key to the syntax analysis. Then among such non-terminals, one such non-terminal will be termed as a start symbol, from where our actual thing will begin. If you see our main, that is our C program, always we used to say that the program execution will start from the main. The program execution will start from the main. How it will be? Main. Then the main will give us the open braces. Then it will be the statement. It will be the statement. Then next will be the your close brace. So now from where we are starting? From main we are starting. So that reason again, main is a non-terminal. Main is a non-terminal. Fine. That is the one such non-terminal is distinguished as a start symbol. And the set of strings it denotes is a language generated by the grammar. Right? So one such symbol, that is from where we start our convention, that we call it as the start symbol. That is symbol is again a non-terminal that you have to remember. Again, it is a non-terminal from where the our actual thing will start. From where our actual thing will start. That is deriving the things. Actual deriving the things will start. That non-terminal we call it as the start symbol. Then the next one, what is left out now? So we studied these things as terminals. Terminals, let me write it as a non-terminal terminals. Let me write it as a T over there. The next is the non-terminals. So for them, we write it as a V over there. Then next we call it as a start symbol. I called it as a S over there. Then the next one will be the productions, means the rule. Right? That we call it as the production as the P. Right? So normally we call it as a VTPS. So VTPS. So V stands for variables, so T stands for terminals, P stands for the productions, and S will be a start symbol. Now, if you go with the productions, so how the productions will be? It will be like let us take your declarative statement. Declarative statement will give us the data type followed by the comma, space, then the variable list followed by the semicolon. Now, if you observe over here, there is an arrow mark. For the arrow mark, we have the two sides over there. One will be your left side, other is the right side. So in the left side, I should have a single non-terminal. In the left side, always I should have a single non-terminal. On the right side, there is no such limit is there. I can have any number. So start from 0. 0 means what? Epsilon. So for the left side, I have a restriction that I should have a single non-terminal. For the left side, I have a restriction that always I should have a single non-terminal. For the right side, I don't have any restriction. And that symbol is used for the, which indicates the deriving. It derives, the left side derives the right side. Left side derives the right side. So each programming language has a different structure. In the YAC program, we have seen that in place of that arrow, we used to write the colon, it will be written. But in this textbook, in place of that arrow, we used to write the colon and the equal to. We will write the colon, that is double colon and the equal to. It has been used. Fine. So that represents arrow only. Fine. And this will be called, that is the left side, we call it as the head of the production. That is the production head. DL is our production head. And this is called as the body of the production. So one will be the head of the production, the thing what is there on the left side. In the non-terminal, what is there on the left side, we call it as the head of the production. And the one what is there on the right side, we call it as the body of the production. So these things you have to remember. Fine. That is in your VTPS combination. V stands for the variables, T stands for the terminals, P stands for your productions. Productions again have the three components over there. That is the left side symbol, arrow, and the right side symbol. Left side symbol we call it as the head of the production. Arrow indicates deriving. Then the right side will be called as the body of the production. Left side always we should have a single non-terminal. Right side there is no such rule is there. Any number may be there. It is a terminal or non-terminal consisting from 0 or more such symbols may be there. So these are the notational conventions what we use. That is your formal definition of the context-free grammar. Formal definition of the context-free grammar. Then next, this example. In this example, so now I need to identify the variables and the terminals. First, expression derives expression plus expression. So this is there on the left side. So this is not a terminal. It is a variable. Term, here it is present. Again, it's a variable. Plus, it's a terminal. That is expression and term, they are variables, wherein the plus is a terminal. In the second example, expression derives expression minus term. Minus is the terminal. These two are the variables. Expression derives term. There is no terminal over there. Term derives a term star factor. Star is a terminal. Rest two are the non-terminals. Term derives term divided by factor. Division is our terminal. Rest two are variables. Then the term derives a factor. No terminal. Both are variables. Factor derives open, expression, close. Open and close are the terminals, and the expression is a non-terminal. Factor derives ID. ID is a terminal. That is, the terminals are ID plus minus star division open parenthesis and the close parenthesis. These are the terminals. The non-terminals are expression, term and the factor. These are the non-terminals which are present over there. Right? So now whenever any expression has been given, any production has been given, how we normally go for understanding what is a terminal and what is a non-terminal. Right? So for that we follow some notational conventions. So even though it is not mandatory, notational conventions are not mandatory, but if we follow these notational conventions, then it is easy to understand which are all the terminals and which are all the non-terminals. Now we won't gain any much this one much use of this one, but if we follow it, then it will be easy to identify what are all the terminals and the non-terminals. First, the non-terminals. For the representation of the terminals, normally we use lowercase letters which come early in the alphabet. So early in the alphabet means what? We have the alphabets from A to Z. A, B, C, up to Z. So normally the one which will come early in the alphabet, we call them as the terminals. Normally we take that one, the one which will come early in the alphabet. And all the operators like plus, minus, star, division, they comes under the terminals. Then the punctuation symbols like full stop, comma, question mark, they comes under your terminals. Then the digits from 0 to 9. And leaving that one, if we go group the characters, so normally we used to bold the terminals. In the textbook, if you see, normally we used to bold the terminals over there. If they come in a pair or more than one character, it will be. In such cases, normally we used to bold that one so that that symbolizes it as a terminal. Then for the non-terminals, we use the uppercase letters. Then the first letter S, which will normally symbolize a star symbol, and a lowercase, but for lowercase we write in the italics. So here we use the bold. For the terminals, we make them bold, and for the non-terminal, we make them as the italic. For the non-terminal, we make them the italic, and for the this one terminal, we make them as the bold. Then, for example, other non-terminals like your ETF, we are going to use, that is the expression, term, and the factor. They are used for the symbol as the non-terminal over there. These are just the notational conventions. Then other than that one, uppercase letters which come late in the alphabet, like your XYZ, they normally represent the grammar symbols, and they can be a non-terminal or the terminal. That depends. Fine, you have to decide. So if it again appears in some of the head of the production, then it will is a non-terminal, or else it is a terminal. And then next the lowercase letters which will come late in the alphabet like U, V, X, Y, Z. Right? So normally we call them as the strings over there. And the Greek alphabet, so that is the Greek characters like alpha, beta, gamma, and all. So we take them as the terminals over there. Then next will be your set of productions like A derives alpha 1, A derives alpha 2. So within common head. So all of them we call them as the A productions, and we used to give the group them as A derives alpha 1 or alpha 2 or alpha 3 up to, so that we can reduce the writing over there. These are the alternatives. Unless otherwise stated, the first production is normally taken as the start symbol. The head of the first production is taken as the start symbol over there. So these are the notational conventions what we follow in this textbook for the terminals and the non-terminals. Right? So now in this grammar, if you observe, so E, T and the F, these are the non-terminals. That is your variables. Leaving that one, plus, minus, star, division, open parenthesis, close, and the ID. They are your terminal. They are your terminals. The head of the first production, E will be taken as the start symbol. E will be taken as the start symbol. That is, these are the conventions what we follow. These are the conventions what we follow in identifying the terminals and the variables. The next, derivations. So derivation is a way of obtaining an input string from the start symbol. Derivation is a way of obtaining the input symbol from the start symbol. Right? So we start with the start symbol in this case. Let us take the example here, then it will be clear. Let me have the input has a open parenthesis E open parenthesis, then I will write it as a ID plus ID. How we get this one? So to get this one, so first what we'll do, we start with the E. E derives T. Then for this T derives F. Then this F derives, so this I will connect here so that it will be clear. Let me rewrite it. So how it will be? First E derives T. Fine. Then what is the next step? Because we have the parenthesis is present under the F. So to get the parenthesis, I should go to F. So now it will be T derives F. Then start from the F, we need the parenthesis, that is open E close. Then again after the parenthesis, I have the ID plus ID. For ID plus ID, it is a open parenthesis E plus E. Then for this E, I will write it as E derives open parenthesis T plus E. Then for the T, I will write it as because the next one is ID. The ID is present under the F. So it is for T, I will write it as a F. T derives F. That is the T derives F plus E. Then for that F, I will write it as ID. That is ID plus E. Again for the second E, I should get the ID over there. How to get the ID? Again the same process. That is now it is open parenthesis ID plus E derives T. Then again T derives F, ID plus F. Then for that F, again it will be derives ID. That is ID plus ID. This is how we obtained our input string. What is our input string? What is our start symbol? E. That is a derivation will give us the way. Derivation will give us the way of obtaining the input string starting from the start symbol. Starting from the start symbol, so that is it will give us the way of obtaining the input. Fine. So that is we begin with the start symbol. Normally how it will be written. We begin with the start symbol, and each rewriting step replace a non-terminal by the body of the production. One of the productions. Then this derivational V corresponds to the top down derivation. That is, we start from the E and we go till the your end. But for the bottom up production also the same convention is followed, but only the applying that one will differentiate. For the top down, what we'll do is now when we have the E plus E, we have the two non-terminals over here. One is this one is this one. So now if I take the leftmost, that is we apply the things from left to right. That is first L. The second one is in this one, if we apply the leftmost derivation, leftmost means what? Now I have the 2E over here. I will take the leftmost and I will apply. That is for the E, I will derive the T, T will derive the F will derive the ID. That is, if I apply the leftmost derivation, then we call it as the top-down approach. In place of this E, if I go for this one, this E derives T, then F, then ID. Then it is called as the rightmost derivation, what we follow in the bottom-up parsing. So bottom-up doesn't mean that we start with the your leaf and we will go to the tree. It is not like that. We follow in both we follow the same approach. In the first approach, what we'll do, we scan from left to right, that is top down, and we apply the leftmost derivation. Then in the bottom up approach, again we scan from left to right, but we apply the rightmost derivation. We apply the rightmost derivation. That is the only difference between these two over there. So now if you take up the example here, so that is E derives minus E. That is this will be head of the production is replaced with the body of the production. Now how we obtain the thing that has been explained. E derives minus E. Then again this E derives it is a ID over there. That is the one what we are deriving. So that is alpha in one or more steps it will derive the alpha. Alpha in one or more steps it will derive the beta. If alpha derives beta, beta derives gamma, means what? Alpha derives gamma. A derives B, B derives X, then A derives X. That is the meaning. Let us take this example. From E, we start the minus E, then minus E close, then E derives ID, this E derives ID, that is minus of ID plus ID. This is for the grammar, E derives E plus E, or E derives E minus E, or E derives this grammar. There is no T and all, directly E derives E plus E, E star E minus E, open E close under ID. The example is if I want to have minus of ID plus ID, minus of ID plus ID. So this can be written as first we start from the E. E derives minus E. Then this E derives minus of E derives open E close. Then again this E derives E plus E minus of E plus E. Then this E derives again the first one I will apply the leftmost minus of ID plus E. ID plus E. Now for the second E I will substitute as it will derive the ID, so it will be minus of ID plus ID. And I right? So this is how we obtain the derivation. Okay. This is what we call the deriving the things. So when we go for applying, there are two concepts are there. One is the leftmost derivation, other is the rightmost derivation. So now in this place, now here no problem, here no problem, in this place. So now I have the two non-terminals over there, one on the left side, one on the right side. If I substitute for the left non-terminal, then it is called as the leftmost derivation. If I substitute for the right non-terminal, then it is called as the rightmost derivation. That is the important point. So that is the leftmost and the rightmost. When we have the two non-terminals in the body of the production, and that is in the deriving part, and if I go for substituting for the leftmost non-terminal, then we call it as the leftmost derivation. And if we substitute for the rightmost non-terminal first, you have to substitute, but if you substitute for the leftmost non-terminal first, then it is called as the leftmost derivation. And if you substitute for the rightmost non-terminal, then it is called as the rightmost derivation. That is the difference. Then next will be the parse trees and the derivation. Parse trees and the derivations. The thing what we obtained over here, the thing what we obtained, how we obtained, that is we start from the E. E derives, what is that one? Minus E. Fine. The same thing what we are deriving here, we are giving the tree representation, hierarchical representation, a graphical representation. So whatever we are deriving, for deriving, we are applying the graphical notation over there. That's it. So that we call it as the tree. That is called as the tree representation. That is the parse tree. So now again for this E, it will be open E and the close. Open E and the close. Then for this E, it is a E plus E. Again for this C, it is ID. It is ID plus ID. So this notation, if you start from reading, you have to read from left to right. Minus open parenthesis, open parenthesis, ID plus ID close parenthesis. Fine. So this will be your input. Fine. That is a graphical representation. Normally, graphical notations are more convenient to follow rather than our other representation of deriving. Fine. So this is what we have observed from the beginning. Usually, the students follow the graphical, can understand the graphical notation easily when compared with the regular deriving steps. That's why this whole thing we call it as a parse step. This whole thing we call it as a parse step. Right? So now if we go with the definition for it, parse tree is the graphical representation of the derivation. Parse tree will be the graphical parse tree. Parse tree will be the graphical representation of the derivation that filters out the order in which the derivations are applied to replace the non-terminals. But in graphical representation, we can't get whether it is a leftmost derivation or the rightmost derivation we are applying. That we can't get. But we start from the start symbol and we end at the leaves. Fine. That order, whether it is leftmost or rightmost, the tree remains the same. So that is here in the leftmost means so this I am going to apply first. Rightmost means this I am going to apply first. But the tree remains the same. But the whole tree remains the same. That is it filters out means it cancels out. So we are not able to identify which derivation we have applied, whether it is leftmost or the rightmost. The tree remains the same thing. Whether we go with the leftmost derivation or the rightmost derivation, the tree will remain the same thing. Right? So that is we can't get the order in which order we have applied. So this is the tree for the minus of id plus id. That is, it will start from the e minus e derives open e close, then e plus e id id. Then next this is the order. Fine. We start from here and it is a step by step. It has been written. Step by step, it is written. The ambiguity we will start in the next session videos. So in this session, we started with the grammars. We started with the what are context-free grammars, and then next we went with the formal definition of the context-free grammars using the four components. The four components are the first one will be your terminals. These are the tokens. These are the endpoints. Then next will be the variables. They need to be continued over there. Then next will be the start symbol. Then next will be the one of the non-terminal. We designate it as a start symbol from where our actual execution or the deriving begins. Then next will be the productions. The productions will have the two components over there. One will be on the left side, right side. Left side we call it as the head of the production. Right side we call it as the body of the production. In between that one we used to have the arrow. Sometimes in place of arrow we used to have the colon and the equal to it will be written. That is a colon and the double colon and the equal to will be written in place of the arrow symbol. Then next we have seen the notational conventions, what we use for the terminals, non-terminals. That is normally the lowercase letters which come early in the alphabet. For the non-terminals, uppercase letters we used to have. Then the bold case letters are used when we go for a group of the characters for the terminals. And we use italic characters for the non-terminals. It is just a notational convention. It is not a mandatory part. The next will be the deriving. So deriving is a way of obtaining the input from starting from the start symbol. We start from the start symbol and we continue, keep on deriving till we get our actual input. Then next we come across the two types of the derivations. One is the leftmost derivation, other is the rightmost derivation. So when we go for deriving, if the leftmost non-terminal is substituted first, then it is called as the leftmost derivation. And if the rightmost non-terminal is substituted, then it is called as the rightmost derivation. Then next we have seen the parse trees. Parse trees are the graphical representation of deriving that we call as the parse trees. Then next, the references for this presentation are taken from the textbook Alfred V. O. Monica S. Lam, Ravi Sethi, and Jeffrey D. Ullman. Textbook name is Compilers, Principles, Techniques, and Tools. It is the Pearson publication, second edition, 2007. Thank you.